Hello there. So I'm going to go over something pretty straightforward today, and it shouldn't take us too much time. What I want to teach you today is it's not working. Let's try again. Better. So I want to teach you how to convert metric prefixes. And you've probably actually learned this skill before in grade school. Maybe your teacher taught you something like King Henry doesn't, chocolate milk, blah de blah de blah. Lots of different mnemonics, ways of memorizing it. And those work all right, although in my experience, rocker students tend to somewhat struggle when they're given that way of doing things. Not because it doesn't work, it does. But you're sitting there trying to remember the phrase, and okay, is there a gap, and you're moving the decimal, and it just becomes messy. That way works for you. You know it backwards and forwards, and it will work great. In my experience, though, you'd be better off doing it the way I'm about to show you. So my ask, though I'm not going to tell you you have to, is you try it my way on the assignment that I'm going to give you in class today to finish. With that, I need a clean board. Alright, well I also need to be in the picture. That's better. So the first thing we need to do to work through this today is we need to get our metric prefixes down again. That table we've already looked at. And so I'm going to quickly get those up on the board here behind me. So you know we have these prefixes from Latin names. And maybe remember they've got some symbols like these. And that the big symbols tend to correlate to big numbers. And the lowercase numbers tend to have small numbers associated with them. Particularly lucky, you also remember there are powers of 10 associated, normally these. Now, I'm asking you to know these for your next test, but right now you've got them in your notes, both in the handed out note sheet that I've given you, as well as the worksheet I'm giving you for the day, and as well as things you've written down. You should have somewhere this table. It's also now in this video if you need to reference that. You'll notice that there's some blanks in the middle, and that's because these are special. These have no prefix. There are base units, the second, the gram, the things like the mole. No, we would rarely use prefixes with the mole, we could. There are things like the liter. And so what they are units that don't need to be multiplied by our power of 10. You know that 10 to the nothing, 10 to the 0 is 1. So it's important to know that if we only have one letter as our unit, or at least one capital letter as our unit, only one thing, just the gram or the second, not the kilogram or the nanosecond, right? Then we're dealing with 10 to the 0th. Alright, so let's go down your notes. On the top of your notes, the first thing I want you to do is remind yourself of something from algebra, namely the power rule for division. You might say, what's that? Well, it's this. That is, that when you have one power and another power divided by each other, and they have the same base, then it's just a subtraction problem of the top minus the bottom's power of 10. I'm just going to pause the video here for a moment so you can add this to your notes. I also want to apologize for the echo. It's kind of hard to report in that lab. Anyway, let's go ahead and go back to the video now, and make sure you do have this a to the m over a to the m business in your notes. So I'm going to ask you to do two examples very quickly. One of them is this one. As we look at it, we know that we have a power of 10 to the 8th and a power of 10 to the 4th. And because these are the same number, I can set up a problem like 10 to the 8 minus 4, or 10 to the 4th power. So all of these are equal. Let's get rid of that. Let's try another one that's a little bit harder. Alright, so here I've got 10 over negative 6, and to most students this looks like it's going to be a very small number, but it's not. It's actually a really big number. Because think about it. I would have 10 to the 3 minus a minus 6. But minus a minus is a plus. So that's the same thing as 10 to the 3 plus 6, which is the same thing as 10 to the 9th, 10 to the billionth, right? A billion of something, 1,000 millions. Just because I put this little million down in the denominator. So be careful, minus a minus is a plus. So that's as hard as our math is going to be today. We just need to know how to take one power and divide it by another. So let's clear the board and let's look at some other examples. And let's look at the rule we're trying to learn today. You'll find a big box in the middle of your notes that says, the big rule for today. Well, let's make the big rule for today. It comes in 3 parts. Part 1. Part 1 is a number that you're given, a number from the problem, a starting value. And we're going to write a time sign and a division sign.
Another quick pause here to write that down.
So once I've done that, I'm going to write another thing, specifically the starting power of 10.
It would be nice to be able to pause things in class like this, wouldn't it?
The starting power of 10. I'll talk about what that means in a minute. But that means we need one more thing, which is the ending power of 10.
You know the drill by now. Make sure you write ending power of 10 down.
And this is our formula. And yes, it seems confusing right now, but all I had to do was move a decimal before. True. But this way will never break. And it uses this information over here that should become very familiar to us by the end of this year. And having these 2 tools together means that these things I am faster at than Google. Honestly, you can test me in class when I come back. It also means you're going to be more precise when you do through this. I promise you I wouldn't teach you this if I didn't think it was better. So let's take this and shrinkify it a little bit and put it up top, and let's look at a couple problems together. So here's the example that's in your notes. Convert 3.3 kilometers to millimeters. So the first thing I'm going to do is I'm going to look, where are my numbers? And my numbers are here, 3.3 kilometers, right? So up here, my starting value is my number I'm given. So I'm going to take that 3.3, and I'm just going to copy the number exactly as it was given. Any powers of 10, any zeros, all of that gets put out front. Then I'm going to draw a time sign and a division sign, and set up the rest of the problem. Okay, the number is attached to a unit, and the unit the number is attached to always will end up on top. That's why I call it the starting value. It's where I'm trying to convert from. So my starting value here is kilometers. So what I'm going to do is I see K. Ooh, I know K, that's kilo, 10 to the third, right? I'm going to take that 10 to the third that I know, and I'm going to write it on top. And that means where I'm going at the end must be the one that doesn't have a number out front, the millimeters. Well, milli, that's got a power of 10 too, 10 to the negative third in this case. And well, I've just set up a problem, right? Couldn't I rewrite this whole thing as 3.3 times 10 to the 3 minus a minus 3. That is this number minus the minus of this, right? So the positive is 3 to 3 to equal to 1, but it's not, it's a negative. So these things combine to make a plus. If they combine to make a plus, then I get 10 to the 6th. And you think I'm done, and you're right, except for one little detail, I need to include the units I'm converting to. And that's really all there is to it. We're going to do this problem and problems like it and call this a day. This is as far as I need you to know how to do it. Again, starting value, value you're starting with, to value you're going to in powers of 10. Do the subtraction and get an answer. Let's look at another example together and have you try it out on your own. The problem reads, convert 4.9 nanoseconds to milliseconds. So I'm going to give you a minute to try this on your own, and then you can check your work against mine. So I get this answer. 4.9 times 10 to the negative 6th milliseconds. Pretty straightforward, if you ask me. Let's try another one, a little bit trickier problem. Have you try it on your own and then check your work against mine. Here we go. All right, I'm asking you to convert 35 milliliters to liters. Again, here comes a minute, and then check your work against mine. I've got a problem, don't I? Because this isn't proper scientific notation. So once I've done the division and everything set up, I can always convert this to proper scientific notation. Now, that's not explicitly necessary because these are the same numbers, and I agree with that. And for the most part, I don't care which answer you give me. As a matter of fact, I don't care which number you give me unless I put in big, bold, underlined words, put in proper scientific notation, in which case I really care which number you give me. So I owe you an apology. My lovely camera here has decided to stop recording things because it's out of battery. It's 9 o'clock at night and I don't have water in the building. So we're going to have to put up with this kind of video. We're going to look at 2 more problems and then we're going to finish this out. Now, your sub will give you a new worksheet here in just a minute.
Yeah, I'm a liar. It's attached to the back of this, so don't look for a new worksheet, it's the one on the back of this page.
That worksheet will have a number of these problems. I know the temptation is just to open up Google and say, okay, let me convert from here to here, and don't do that. I'll put an answer key up or I'll answer questions in class. I'm not sure exactly how that's going to go yet. It just depends on when we come back to school. But don't go Google these. And the reason why I'm saying that isn't just because I'm like, they won't get it done in 5 minutes and they have nothing to do. No, the problem is this. If you just go Google them, you're not learning the skill which I'm really asking you to learn, which is this A to the M over A to the N business. So let's look at one more problem together. I'm going to erase this board and make it nice and clean here because, well, this camera isn't have the resolution that this camera does. And let's look at those last 2 problems on your note sheet together. So here we go. All right, so here we go. I want to convert 350 kilometers to centimeters. And this problem should go pretty smoothly for you. So if you've been struggling, let's talk through this problem. The first thing I'm doing is taking that 350, I'm multiplying it by 10 to the power of the number I'm going to, something along those lines. Remember, kilometer is 10 to the negative 3, cent is 10 to the negative 2. So I set this up and I can write it out, and I should get 350 times 10 to the 5th. But I'm not done there if I told you write it in proper scientific notation. If I told you to write it in proper scientific notation, I can't have a number bigger than 9 as a coefficient. So I need to take that decimal and bring it over twice. So I get like 3.5, and because I made the number smaller, that is, this is a big number, I've got to raise the exponent. Now, again, on a test, on a quiz, on my class, if you write the top number, I'll give you like 80% of the points. This is the difference between the A and the B on the test, is knowing, oh yeah, that's right, I've got to put it in proper scientific notation when he says. With that in mind, let's try one more problem together, where I put it on the board, you look at it, you check your work against mine, and then you should start your homework and finish it for the day. Depending on if we actually end up doing this one on Friday or Monday, there'll be another video. Or you'll come back to my class and we'll deal with it. We'll deal with accuracy and precision, and then the lab that we were going to do this week before water main happened, we will do next week on, well, let's say Wednesday, Thursday, and probably honestly Friday we'll do lab safety. So I do promise the chemistry side of things will become a little bit less drudging. In the back of your mind, with that happening then, and let's see, density early next week, plus a lab early next week, it may be as soon as next Friday that we're looking at a test. So again, this Friday of this week, Friday of next week, the Friday thereafter, we should have our first test somewhere in that neighborhood. We'll help refine that. So with that, let's go ahead and look at one more problem really fast. Okay, I think this is the hardest problem possible. Convert 35 nanoseconds to seconds. The hardest problem I can ask you, and I'm still only going to give you 1 minute, so here we go. All right, so you should have gotten 35 times 10 to the power of negative 9 nano divided by 10 to the 0th, because seconds is a base unit, which of course just tells me 35 nanoseconds, 35 times 10 to the 9th. What bites students in the butt here is they forget that because there's not a prefix in front of seconds, just because it's seconds and only seconds, well, they have to write it times 10 to the 9th. That, right? Because the seconds itself is 10 to the 0th. And of course, this number needs to be made a little bigger, so it's actually times 10 to the 8th, and it goes there. Give it your best shot. I'll check in with you when I'm back. I get back from the wedding Tuesday morning, so we'll be there. And otherwise, I hope you have a great day, and thanks for your time listening to this. I hope it makes pretty good sense. If you are stuck, shoot me an email. I should have access to my phone. Washington isn't that rule. So I should be able to respond to you and let you know where you're stuck on. Just take a picture with your iPad or whatever of the problem you're stuck on and say, hey, here's the thing I tried, here's how I did it, and I'm not sure I got the right answer. All right, see you soon.